Hello viewers, in this video we're going to learn about the volume of compound shapes. And to start with, the compound shape is a shape that is made up of several simple shapes. Could be two or more simple shapes that are joined together to form a complex or a compound shape. And to calculate the volume of such shapes, we need to deconstruct or split up the compound shape into the several simple shapes that make up the complex or the compound shape. Then we calculate the volume of the individual simple shapes, then add up everything together to form or to give us the volume of the compound shapes. And we have several examples here on the board. Let's start with example 1. Example 1 is to calculate the volume of the following shapes. This one, let's call it A. Let's call this one A. And let's call this one B. So to calculate the volume of a shape like this, starting with A, we need to deconstruct the shape, split it up to the two shapes that make up this complex or compound shape. Right on the top here, we have a prism and a triangular, no, this is a rectangular based prism. The rectangular based prism right on top, and then on the bottom is a cuboid, which is also known as rectangular prism. So you calculate the volume of this prism on top, calculate the volume of the prism below, add up the two to give us the volume of this compound shape. So let's start with the volume of the prism on top. A volume, let me call it prism 1. Let me call it 1, and let me call this one 2. So volume of 1 is a rectangular based prism, and from our previous class where we learned how to calculate the volume of prism, we usually multiply the area of a regular cross section or a uniform cross section by the height of the prism. So in this case, the base of this triangle, or this prism rather, is rectangular in shape. The area of that rectangular shape multiplied by the height of the prism, which is indicated by this arrow here, 9 feet, will give us the volume of the prism on top. So that would be volume of a rectangle is length times width. The length of this is indicated here as 12 feet, and the width is this line right here, which is the same thing as this 4 feet here. The area of the base is 12 multiplied by 4, which is 12 times 4, that is 48. Therefore, volume of this, then times this height right here, times this height, which is 9. 48 times 9 is 432. The volume of the prism on top is 432 feet cube. Now, volume of the prism below, which is a rectangular prism or cuboid, let me call it volume of 2. Volume of a cuboid is length times breadth or times width, then times height. The length here is 16 feet. 16 multiplied by the width, which is 4, and the height, which is 6. So 16 times 4 times 6 will give us the volume of that prism below. 16 multiplied by 4 is 64, and 64 multiplied by 6, 384 feet cube. Therefore, the volume of this shape as a whole, volume of the shape is the volume of the prism on top, which is 432 plus the volume of the prism below, which is 384. 432 plus 384 is 816 feet cube is the volume of this prism. Let's move on to question B. For question B, I have a hemisphere right at the bottom. Hemisphere is half of a sphere. I also have exactly the same hemisphere on top. Then in the middle is a cylinder. So the volume of this hemisphere, let's call this one 1, plus the volume of this cylinder, let's call it 2, plus the volume of this hemisphere, let's call it 3. But since this and this are exactly the same, I will just multiply their volume by 2. And we know that volume of a hemisphere is half of a sphere, and volume of a sphere is 4/3 pi r cube. Therefore, volume of hemisphere, let me call it volume subscript h, will be 4/3 pi r cube divided by 2, which is 4/3 pi r cube multiplied by 1/2. 4 times 1 is 4, 3 times 2 is 6, so 4/6 pi r cube is the volume of the hemisphere. So I have two of the hemisphere here, the one here and the one here. The volume of 1 and 3, let me join them together. Volume of I and I will be 2 times this. 2 multiplied by 4/6, multiplying them by 2 because they are exactly the same. This hemisphere on top and this hemisphere below, they are exactly the same. And the radius is 6 meters. 2 times 3.142, which is the value of pi, approximate value. Then the radius is 6 to the power of 3. Let me plug these numbers into calculator. 6 cube is 6 to the power of 3 is 216. 216 multiplied by 3.142, then multiplied by 4, that is 2714.7 approximately, divided by 6, this 6 right here, divided by 6, that give me 452.5 approximately, then multiply by 2, 904.9 approximately as the volume of this hemisphere and this hemisphere. Now let's get the volume of this cylinder. The volume of cylinder, let me do it here. The volume of cylinder we know is pi r squared h. That is, and the cylinder here, the base is sharing a base with this hemisphere, and the radius is 6. So 6, pi first. Pi is 3.142, approximately 3.142 times the radius, which is 6 squared, times the height of the cylinder is 11 times 11. That will be 3.142 times 36. 6 squared is 6 times 6 times 11. Let's plug those numbers into calculator. 3.142 multiplied by 36 multiplied by 11. That is 1244.2. 1244.2 meter cube. I'm not been putting the unit. This is supposed to be meter cube. Therefore, volume of the whole shape will be the volume of the two hemisphere, which is here, plus the volume of the cylinder, which is here. Let's add up the two to give us the volume of the shape. 904.9 plus 1244.2. Let's add them up. Plus 904.9. That is 2,149.1. 2,149.1 meter cube is the volume of this compound shape here, shape B. Okay, that brings us to the end of this example. Let's move down to more example. I have example 2 here. Again, several two compound shapes, not several, two compound shapes here. For the first one, again, let me label this as A and let me label this as B. And as a disclaimer, I got these images from Math Worksheet for Kids. A very good website you can check out if you want to get shapes like this to practice on your own. Then for this A, I have a hemisphere right here on top of this rectangular prism. So volume of this shape would be the volume of the hemisphere plus the volume of the rectangular prism. And from the first example, example 1, we have established that the volume of the hemisphere is 4/6 pi r cubed. The volume of this hemisphere, let me call it 1 and let me call this 2. The volume of 1, which is a hemisphere, V of 1 is 4/6 pi r cubed. As we earlier established here, this is volume of a hemisphere. Hemisphere is half of a sphere. So when you divide the volume of a sphere by 2, you get the volume of a hemisphere. So this will give us 4/6 times pi, which is a constant, 3.142 times the radius. The radius of these, look at it, from here to here forms the diameter of the hemisphere. And that diameter is exactly equal to this 8 right here. This length of line and this length of line are the same. So if diameter is 8 centimeters, what will be the radius? The radius is diameter divided by 2. That is 8 divided by 2, which is 4. So the radius of that hemisphere is 4 centimeters. So let's plug that into here. I have 4 to the power of 3 right there. Putting these numbers into calculator will give us 4 to the power of 3 is 64. 64 multiplied by 3.142. 3.142 and then multiplied by 4. That is 804.4 approximately. And divided by this 6. Divided by 6. Volume is 134.1 approximately. Okay, that's the volume of the sphere right there, and the unit is centimeter cube. Now we need to get the volume of this second shape, which is a rectangular prism or cuboid. And volume of a cuboid is length times width times height. That will be, the length here is 12 centimeter. The width is 8 centimeter. The height is also 8 centimeter. So 12 times 8 times 8 will give us 768 centimeter cube. So volume of the rectangular prism is 768. So the volume of the whole shape will be the volume of this prism, which is 134.1, plus the volume of this prism, which is 768. So let's do that here. Therefore, volume of the shape will be 134.1 plus 768. And 134.1 plus 768 is 902.1. 902.1 centimeter cube. It was the volume of this shape right here. Let's move on to the second one, that is B. For B, we have a prism right here on top, rectangular base prism. And we also have a prism down, which is a cuboid or a rectangular prism. We will first calculate the area of this prism up, and that's the area, the volume rather. The volume of this prism up here, let's call this prism A, and let's call this prism B. The volume of prism A plus the volume of prism B will give us the volume of this whole shape. And to get the volume of that prism on top, we need to multiply the area of uniform cross-section by the length or the height of this prism. The uniform cross-section is this triangle right here, which is the same triangle at the back. And the dimension given, the base of this triangle right here, let me highlight it, this base right here, is the same, this 14 inches here, while the height is indicated with arrow here. The area of this triangle multiplied by the length of the prism, which is the same thing as this 9 inches here, will give us the volume of the prism on top, which we call prism A. I have messed it up with this drawing then. Let me remove them first. Okay, so this is prism A. Let's get the volume of that. Volume of A is area of this cross section here, which is a triangle, R times base times height, the area of the triangle, times the length or the height of the prism, which is the same thing as the length of the prism below, 9 inches in this case. So times 9. Okay, let me place it as L first, since I'm not putting the value here. And the base of the triangle, as I stated earlier, is right here, which is 14 inches. That will have 1/2 times 14 times the height of the triangle, which is indicated with arrow there, 5. That is area of this cross section multiplied by the length or the height of the prism, which is 9 inches, multiplied by 9. And let's clear this out. 2 there is 1, 2 here is 7. 7 times 5 is 35. 35 times 9. 35 times 9 is 315. 315 inches cube as the volume of prism A, the prism on top. And let's give volume of prism B. Prism B is a cuboid, a rectangular prism. The volume is length times width times height. And the length here is 9. Okay, this is longer, 14 is longer, so length is 14. The width is 9. And the height is 8 right there. So 14 times 9 times 8, I wrote 9. 14 times 9 times 8 is 1008. 1008. What is the unit? Inches cube. Therefore, the volume of the shape would be volume of prism on top, which we call prism A, plus that of prism B. So the prism A is right here, 315 plus prism B is 1008. Add up the two numbers, we have 1323, 1323 inches cube as the volume of this prism. Okay, that is that for example 2. Let's have one more example left. Example 3. It is right here. Again, let me label this as A and I label this as B. For A, I have a prism right here on top, which is a rectangular prism or a cuboid. I have the same rectangular prism at the bottom. So the volume of A plus the volume of B will give us the volume of this shape. So let's work it here. Volume of A is a rectangular prism, so length times width times height. The length is this line here. Let me highlight it. This is the length of this prism on top, which is the same thing as this 7 millimeter here. 7 multiplied by the width, which is 5, and the height, which is also 5. So 7 times 5 times 5, that is 175 millimeter cube as the volume of the prism A. Now volume of prism B again is a rectangular prism, length times breadth or times width times height, which is the length here is 13 millimeter, 13 multiplied by the width 7 millimeter, and the height 4 millimeter. 13 times 7 times 4, 364 millimeter cube. Therefore, volume of the entire shape, which is volume of prism A plus volume of prism B, 175 plus 364, that gives us 175 plus 364 is 539, 539 millimeter cube as the volume of prism of this compound shape ring. Now for question B, I have a hemisphere on top right here, and I have a cone below. So let's call this hemisphere, let's call it A. Let's call cone B. The volume of A, that is question B right there. Volume of A, since A is a hemisphere, we stated earlier that volume of a hemisphere, we use it somewhere. Where is it? Let's go back there, refresh our memory. Volume of a hemisphere, this is volume of a sphere. Half of a sphere is called hemisphere. Volume of a hemisphere is 4 over 6 by r cube. So 4 over 6 by r cube is the volume of this hemisphere right here on top of the cone. And that will be 4 over 6 multiplied by pi, which is approximately 3.142. The radius of the hemisphere is 10 to the power of 3, which is 1,000. So 1,000 multiplied by 3.142 is of course 3,142. Then multiplied by 4 is 12,568. Then divided by 6. Divided by 6 is 2,094.7 approximately. 294.7, and the unit is centimeter cube. And the volume of the hemisphere on top. And let's get the volume of cone. The volume of cone. Cone is a circular pyramid, a circular base pyramid. The volume of any pyramid is 1/3 area of the base. In this case, the base of a cone is a circle. An area of a circle is pi r squared. Then multiplied by the perpendicular height, the vertical height of the cone, which is h, and is indicated as 15 centimeter right here. So I'll have 1/3 multiplied by 3.142 multiplied by the radius, which is 10 centimeter to 10 centimeter square, multiplied by the height, which is 15, and 10 square is 100. So 100 times 15, 1500, then multiply by 3.142, 142, multiply by, okay, no, not multiply, divide rather, divided by 3. I think I made a mistake there in my calculation. Let me rework that, my calculation. 100 times 3.142 times 15. Okay, 4,713 divided by 3, 1,571, 1571 centimeter cube. So we know the volume of prism A, or hemisphere rather, A, and the volume of cone, which is B in this case. The volume of the entire shape will be volume of A plus B. The volume of the shape is equal to volume of A, which is right here, 2094.7 plus 1571. Add up this with the calculator. 2094.7 plus 1571 is 3665.7. 3665.7 centimeter cube as the volume of this prism. And that brings us to the end of this lesson on the volume of compound shapes. I hope you found it useful. If you do, don't forget to subscribe to my channel and also like the video so that you get notified for more content.